An experiment of DevTalks. Is the first open talk ever. So here is how it's going to work. I have some slides, and starting from this, we can talk, we can exchange information. I like to hear your opinions. Otherwise, it's going to be a stand-up thing, so I'm going to talk, so it's not like you're forced to say anything. So first of all, I'm Andrei. I'm an IoT architect at SHE, a company from both Germany and Cluj. And I'm going to present how to present to the users the IoT data. So it's not many of us, but let's be on the same page. This is how an IoT network really looks like. First of all, we got data from sensors, and sensors usually are active or passive. They are connected to a sensor node via wire. Basically, sensors need power in order to sense the environment, and the environment is changed via actuators. So let's say we have sensor temperature sensors, whatever, and the actuators are switches, on-off switches. And then we have sensor nodes. Sensor nodes are active devices, programmable devices, which can connect directly usually to cloud. And they send data, and we'll see next what kind of data. Sometimes, if we imagine we want to monitor an area like this one, we need some gateways, one, two, a couple of cluster of gateways, depending on how reliable we want the system to be, to which the sensor nodes connect, usually wireless. And it's important this because we need to measure some information there as the power of transmission, the quality of the transmission. And then usually the gateways, as the sensor nodes in some cases, connect to the cloud. The cloud is in charge of keeping caches, of presenting the data. And then there is the presentation layer, which can be browsers, phones, whatever accessories. One thing to remember here is that IoT systems are very present, influence our life every day. And one example to be is, it doesn't matter if we have a tool that gives an error, but it matters a lot if our heating system at home is not working properly. It's raising the heat in the summer, or I don't know, setting the heat to 8 degrees in winter. So we feel it very well, and this could be also a very minor bug. In a regular system we do, probably it will be just a text where the desired temperature is not right, but here we feel it. That's one way. And also, when you think about interaction, we need to take care, because we are now, when talking about IoT, we are going into systems that are there for a while. For instance, interacting in regular apps, we invented the OK and cancel buttons, right? But this was invented by developers. Users got used to it because we proposed to them. But imagine the door lock. Everybody has been in a hotel where you have that card. It's not a key, right? That's basically a sensor in our system. So that sensor had to be put there where the key was. It represents the key, but actually it's something totally different. It's a sensor in an IoT network, but it had to be there because it has to have the same behavior as the regular system, the analog system. Okay, let's see what kind of data we want to present. So, if this would listen to me. Okay, so we have the network. First of all, every sensor has a value. It doesn't matter what it is. If it's temperature, if it's humidity, if it's presence, it's a value. Usually a number value, a float value, or if it's a binary sensor, a one or not, presence or not presence. Sometimes it's statistically, it's the percentage of having a presence in this room, right? So it's a value, always it's a value. What's also important is the timestamp, when that value happened. So the most basic thing we want to keep in the DB, it would be an ID for that sensor, a name, somehow to identify it, a timestamp, and for that key, we'll have a value. Usually, this is what we want to display. Now, Sometimes we also need to see the battery of the sensor node. It's important because if it will drop, we need to change the battery. It's important. Also, as I said, we are working in a wireless environment. It's important to see the quality. Sometimes we do not see values. We do not see inputs, and the node is offline, and we want to know why. And if we see that the RSSI this is the quality of the wireless signal, it's low, then we may have a clue. So all these are kind of what are called secondary values or extra values. So now if we imagine a more complex storage, a line would be the timestamp, the iSensor ID, the main value, and a lot of extra values that happened in the same timestamp. Okay, so this is what we want to display. Now when? This is very, very tricky. Systems, IoT systems are, regarding time, are separated into three main things. Live. Live means to see enough values, to have enough values to see all the changes. For instance, temperature. It's okay if you see it every 10 minutes, every half an hour. It won't change a lot. But if it is a system, I don't know, a heating system of a nuclear plant, for instance, where if the temperature can rise a lot in 1 minute, we need to see less changes. So live is having enough accuracy to see enough changes. That's the lightest thing. So when we have a live system, what will we have? Usually things that get the data, like I don't know, a screen that makes pulls, an app that makes pulls. Sometimes notifications are not needed, just in case of alarms. We may have events configured, alarms that, I don't know, so the heating is, let's go again with the temperature is very high or very low. Then we need to send an alarm, a notification, whatever the environment would be. When we are talking about real time means we need to see all the changes. But still, if we do not see all the changes, people will not die. So, and there we need to see basically notifications, always. Always we need to notify, okay, that sensor info has changed, that value has changed, everything has changed. When we talking about hard real time, this means if we do not see some changes, people may die. And think about the steering of a car, right? Or the brakes. Or we see we are in I don't know, 100 miles per hour in a left turn, and we need the adaptive steering with a sensor there will detect that it needs to be, I don't know, one wheel to be turned 1 more degree. And then what we expect, to have a notification and to say, okay, I did it, okay, do it, we'll die. We can't do this. So usually at that point, decisions are taken by the system, and we notify the user with what happened. So it's just an information there. It's still a notification type, but this happened, this decision was taken, and this is the new status. Not like, do you want to do something? So be careful, it depends. This is very important to when we send. Okay. So, by the way, I told you can interrupt me anytime, we can discuss. Okay, now let's move to how. Well, we have to think about our users. Users are not necessarily technical users. Users are, it can be, we have a system we build, and we call it the tech view. Here is called simple view, but actually we call it the grandma view. So imagine your grandparents. Maybe some of you have technical grandparents, but imagine the non-technical ones. These persons should be able to use those systems even they haven't used a computer before. So, okay, we need to have screens at some point. These screens can be anything, tablets, can be TVs like this. You just see some information. A TV is not something technical anymore. But the question is what we display there and how we do it. So there are two things here. This is actually a monitoring system for the light. This is in my office where I work. We have an issue there, who turns on, who turns off the light, and then okay, I said I'll be the monitor system. So what we did, we have a photo cell that gives us a raw value, and then based on that raw value, we say it's on light or not. We have enough light or don't have enough light, and we have some angles also. But let's stick to the have enough light or not enough light. So here, do you see it? No. So here is the simple view. Just depending on what is the level of light, this yellow area will go lighter or darker. Here is the maximum light ever possible. Actually, this is the hard-coded value because no sensor will give like this, but this is hard-coded value. So we'll go lighter or darker. Now this is for everybody. It's intuitive. Everybody could see it. If it turns on the light, it goes lighter. Turns off the light, goes darker. This is the grandma view. Now, the other side, you see there are two sensors here, two graphical representations. This means the raw value of the sensor. It has the ID. If my grandma would see the ID at 3, say, what's that? And then the amount in lumens. I'm not sure actually if that's lumens, but that's the raw value. So this is useful for technical people, right? Now imagine that this system is not just for play. It's a system where a plant or this room is managed. Somebody from technical would be able to see this. Now, our ability is how we can adapt our system to be able to present the right data to the right type of users. And that's something that we can either hard-code it and ask what type of user it is, or it can go all the way to AI and try to identify that type of user, try to see what their actions are, try to identify a profile. So whenever implementing a system, please be careful what type of the user is. Okay. Here what I'll show are some images from an app that I'm working on. It's a hive monitoring app. So we are monitoring the weight of the hives. This is important for beekeepers, and we have several ways of presentations, and this is actually where this idea of this talk came from, because I interacted with a lot of users, all kinds of users, and they asked me for different things. So first of all, we have this graph, this dashboard-like view. So the blue line, it's actually the weight, and it's for 4 days, I guess, there. And you see it's where there is that line, there was honey was collected, and the beekeeper was there to check it, and then we see honey was collected here, and then the new frames were added, so we can see all kinds of events. And in the first 2 days there, we can see that it raised, and acacia was flowering, and so on. Okay, this was cool. But then we had like more technical users who wanted to see, and this is a Romanian word, what's the time? They wanted to see it from a strike of hand. I wanted to see the weight of my hive. Usually there is one hive which is monitored. So we implemented this. This is the watch face. What we implemented is that small widget where it shows 43.3, and we show there 3 types of information. The main value, we'll see, and the connectivity, and you see the line around it, the circle line, that's the battery power. After that, of course, not all the people had these smartwatches. You need an Android Wear smartwatch, so people wanted to have the same experience, but with regular devices. So what was next? It was the phone. Say, okay, come on. And we built this kind of widget. Let's see it bigger. This kind of widget. So it's a widget that refreshes itself. The user will take the phone and just see it. So we have there the value, the main value. We have the connectivity, and we have a couple of extra values. The 22 is the temperature. That's important for beekeepers. Here we did not have space to show it. And then there is the battery also. Okay. Now let's go a little behind the scenes. What happens? So when we want to present this type of data, well, this type is just the raw values. But what if we get values every second? We could do this, and we want to display the data for one year. In the minimum size of the just one integers for IDs, timestamp should be a log integer, and for values, the data, what I said, it's around 30-something megabytes. That's the lowest thing possible. So basically, when this is reloaded, 30 megabytes are transferred from a server to the device, to a phone could be. But on the phone, we see only like what? 1,000 pixels. So we have from 36 million pixels data, we have like 800 or 900, what can you see, because have some margins. So then a lot of data is not taken, and you see, even if we draw a lot of pixels, there will be only one pixel, and probably will be only a lot of noise there, so we won't see anything useful. So what can we do is aggregate data. Just display, get as much data as you can display. So what we can do, we can have averages. For instance, and there are all kinds of formulas, not necessarily arithmetic averages, but all kinds of formulas. And what should we do is just get only, maybe not 800, maybe not 1,000, but let's say 1,000 points, data points, and from that we can have the same graph, the same chart. It will be there. Now, what happens when we zoom? Because is down. So when we zoom in to see the data for 1 month, now the initial data, or for 1 week or 1 day, the initial data would not be enough. So then we can take the data on demand, right? We want the data for 1 week, we take it on demand. We have the tools on every system, web, mobile, we have the tools to take data on demand. The idea is to have the system ready for this. This is if you want to support a dynamic zoom and to move all around the chart. A trick that could be done is having predefined intervals. What I have done there. So I do not give the user the possibility to see the data for, I don't know, last 52 hours. He doesn't need it. He can have 1 day, 4 days, so it's enough for them. Actually for these 5 predefined intervals, I had no complaints whatsoever. So yeah, these are studied. The 4 days we added after, but afterwards we had no complaints. The big advantage on this is that we can really pre-calculate this overnight. So today, this midnight, we're going to calculate all the data until yesterday. And we can have this system implemented in place. The amount of data is basically, the data will not be duplicated, but around 70% extra in the database. But the speed of delivering the data is awesome. So we have pre-calculated data for days, for last 4 days, and we aggregate the data since today with the data for all year. Yeah, we could have cases where we want all the year, all the month. This is where it hurts a lot. And having these tricks, with the one with Zoom, you can get about 97% of the data not getting carried. So from those 36 megabytes, we take only 3% of the data for the monkey user, the user that wants to do all kinds of zooms. Basically, you cannot zoom every hour in a year. Nobody's going to do this, or it will take them a few days. Yeah, so the amounts are awesome. The efforts still are very big to do this. Okay, this is a totally different story. Here, we do not display graphs. We do not display everything. We display only one value, the last value. So it's always the last. And And imagine that what would happen. We have a database, and we need to query where the time, sort it by time, and give me one value, the top value. But what we can do also is cache that value. So we don't even need to go to the database, because it's one value for one sensor. And imagine how many sensors can we have? Okay, we can have like 1 million sensors. What it would mean to have 1 million sensors to have that record? It's what? Could be 1 gigabyte. We have that kind of RAM today. It's $5. So we can keep it there, actually. And it's very, very important to do this. As I said, come on. So it is important also, as I said, there is the timestamp. It is important how we represent the timestamp. Timestamp for me here, it's an integer, the number, how many milliseconds from what was spent from 1970, 1st January. I could have displayed that, but that's not useful. So what I displayed instead was the other way around. What is the amount of time since the sensor last sent data? Because basically that's what the user is interested in. And how do I do this? I could say 20 minutes, 30 minutes, but then I get a lot of calls from users. Oh, my Hive didn't send data for 10 minutes, for 15 minutes. What happens? So I know how the system works. I know how often the system sends. And what I do, I give an indication, a graphical indication to the users. Your sensor is okay. That's all he needs to know. There are also 2 other icons. One is for when one time the data was not sent, and when 3 times was not sent the data, then we consider the sensor offline. But it just gives a warning, and then it's offline. Just these 3 types of information is what people need. Why is this? Because we have that kind of user that this is what data they want. This is what kind of data they want. And the same thing happens into the watch. Now, I talked about what kind of data we send. So there is the last value is the main value. It's big. The user, this is what he sees. He doesn't even need to know that these are kilograms, because he knows, because this is what he is looking for. When he's looking to a scale, there is not written kilograms, or maybe it's written but it's very small. So the user see that number, he knows what's. Yeah, there are those electronic scales that have pounds and kilograms, but generally they see it. And then the extra values are smaller. Does the user wants to see them or not? Again, the unit is not important. The only thing we had here is that somebody, just one person out of our users, thought that 80% is the humidity and not the battery power. But after that, we explained to them, they even came, so in our system, we never charge the battery above 80 to 83%. We will try 80, but since computing DC voltage, we get about 82%. We want to keep the battery lifetime. So, and they asked, why is not charging my device? So they saw that information. And this is how we got the feedback that they really needed it. Okay. So what I haven't told you at the beginning, that the open talks are short. I told him that I'll keep it for an hour, but actually I lied. So if we can open for questions, we can talk, and we can keep it for, I don't know, we have like 10 more minutes. I guess everybody left? No.
For example, you said there the weight is 43 kilograms. The user is always aware of the maximum value. So basically what I'm asking, why shouldn't it be better for the last value to be represented also as a percentage?
So no, there is no percentage. Actually, we weight a Hive. That's the weight of the Hive. So the user knows what it started from, and it started from, let's say, 30 kilos, and it says, okay, now it's 43. This means I have around 13 kilos of honey. So it's not a percentage. Yeah, percentages are important to know that are percentages. So percentages there, we notice that. Or with graphical represent. Graphical is better, but we had no space there to put also an icon to see that. It's important to see that it's half or it's below half. So we experimented with an icon. It was pretty small. We had only four intervals: 25, half, 75, and user usually saw 75, which is 80, 75, and 50. So they were concerned about the big drop. So then we put, okay, we'll put the number there.
How many clients or people are currently using the product? How many people are using it? Is it still under development, or do you have it installed and running in real time, in real life?
It is installed in real life. So the number is not so big. There are around 10 now using it. This system in place. So customers, there are around 10 customers, and there are I don't know. We have a lot of. So, okay, I'll give you some insight. This is an app that helps beekeepers. Okay, for this app we have a lot of customers. Now, the hardware part is something more like experimental. It's not like something we are selling yet, and we give it to some customers to try it, to play with it. It's an ad. It's for the special customers. Now we have around 10 customers that wanted to acquire this. And we gave them some offers. It's renting to them. But we have including us, because the founders of this are beekeepers, all of them. We have I don't know, around 20 systems in place, but working. And it's usually always my system is never working because I always experiment on it. And so I actually considering making a duplicate now, to have one in place and one. So this is my system, but actually it's my system there, but it was not on my API. I borrowed it to somebody, and then he used it properly.
You talked about how important it is to have a good graphical interface for different values. Why didn't you use on the battery level, like the battery icon on the phone? Why it is important to have a percentage? Do the users care about?
As I told you, it was an icon, but it was so small, and they saw only 75 and 50. So because usually we are there between, and they saw a big drop, and come to questions: what happened to my scale? The drop was too big. It was almost full, and now it's half. It will die. It's important that system not to die when actually it has a solar panel on it. It's important not to die when it's monitored. Actually, it's monitored. I don't know, 2 months a year, things like 3 months a year, and that month it's important for the beekeeper that system not to die. So, and then we put them the percentage.
I have another question. The app, the image, to say like that, it's for one beehive. And for example, if you have a beekeeper that has 100 beehives, you will have 100 icons? Or what's the solution for multiple hives?
Okay, so again, some beekeeping insight. So usually now, people that are not using this system have an analog scale that is one average hive on it. This is the scale, the hive with the scale. This is how they call it. And then, based on that, they can realize what happens. Yes, if you'd have one scale for each hive, you'd have 100 icons. What we can do is, I'm not sure you saw that big trucks with a lot of hives. Yeah, so what we do is put actually 2 load cells on 1/2 of that truck, and we measure all size. So there the weight will be in tons, it will have thousands, and then the accuracy is bigger because you see, you do not have to, what you do, you basically see, okay, I have 13 kilos in this hive, I have 100 hives, I have about 1.2, 1.3 tons. You don't have to do this anymore, you have the whole sum of it. This is the solution we provide. But honestly, this was only experimented once, and it's not in production. So I don't think we're gonna put it in production. So, but this is the solution. What you do, and beekeepers usually want one. They do not care about all of them. They want to see, and the information is not like they want to see how much honey. What they want to see are two things: when honey collected started, and when it stopped. Because imagine one beehive, one colony uses about 2 kilos of honey per day in this period. And acacia honey costs like 50 lei per kilo. So if they lose 2 days and not taking out the honey, then they probably lose 200 leis for that hive. So this is what they want. When it stopped, when the raising is not so high, they go and collect. You see? You see there? So here, the beekeeper noticed, here is the day, right? The beekeeper noticed this raise was not so big. So what happened, the next day, he waited and then he went to check it. He did some operations here, and here he got the honey out. Because these 2 days were about to eat it. And then you see, the raise was not so big, and here he added one more super, but the gathering was not so big. Okay, are we done? Okay. One more.
One final question. Did you encounter any, let's say, problems or challenges with the hardware while in production? Like, can you explain a bit about some things you haven't thought about, but you kind of stumbled upon them?
A lot. So, first of all, the biggest issue we had is, the load cell. The load cell is the sensor that measures weight. That load cell is influenced by temperature. It's balanced. What we have, so there are load cells that cost $10 as ours, and there are load cells that cost $200. Now we said, okay, the $200 are more balanced. Ours is not balanced. We try to do some algorithm, but then in the end we end up checking ours to a special company that sells those 200 cells and has consultancy, and we concluded that ours is better than the $200 one. It's more adapted. But still, between 0 and 30 degrees, we are losing about half a kilo in our weights. That's not acceptable between day and night for us. Yeah, if we can do, we studied what competition does, and what they do, they always measure the weight at the same time of the day. Actually, this is what beekeepers do in real life, with regular scales. So each evening would be about the same temperature, so it not be influenced. But we wanted to have it daily. So this is why we added that temperature sensor. Now, the temperature sensor, it gives us the temperature of the environment, and since the cell is linear, then we can compute it with an accuracy of 20 grams, which is enough. The cell is 200 kilos, so it's very good. But then we had different types of temperature sensors, and we have one that sometimes, we don't know when, it gives us errors like 160 degrees, minus 200 degrees. So then we have a lot of spikes. What we did here is replace the sensor. And we also had one other issue with the load cell. We had again those spikes sometimes, because the load cell uses an amplifier, and that amplifier is influenced by anything. First of all, we stopped the GSM. So the modem is not connected while we do the measuring. And then what we did an average. We did like 50 measurements in 1 second, or it takes between 1 and 2 seconds. And we sorted them, and we took 5 to 45. So the lowest 5 and the highest 5 we eliminated and made an average out of the middle 40. So, and doing this in test environments, we have like a mini incubator, to call it like this, and where we can control the temperature and we can control different things. We have errors which do not go higher than 20 grams. So we have scales, we have weights that are controlled. We know what they are, and we put them there, and these are the averages. So this is what was the hardware thing. What we experimented now, and this is very hard to test. We tested the solar panel and the battery, and I was able to test this during the winter, and I put it the update to be every 3 minutes, and I was able to make it die during some cloudy days. So the panel not to do it, not to be able to charge the battery, to see how it happens. We had some issues, we fixed them, but now we have some issues with connectivity. Where we do not have connectivity or the connectivity is poor, sometimes we lose some data. So there is a bug somewhere, but it's very hard to test. We are testing it with we added some aluminum foil on that testing environment, but still the signal in that area is very good. So we need to move somewhere outside and do some tests there, and hopefully we'll be able to reproduce, because it's reproduced only on one scale. So we are not sure what happened there. So testing is extremely hard in IoT system if you talk about hardware, extremely hard. Because you have to reproduce exactly the same environment where it happens. And sometimes you cannot. It's influenced by, you don't know why. It's some relay at some provider was having some troubles. And then this happened. So yeah, these are the issues we faced. Okay, thanks a lot.